Shora College has 3 campuses, north, west, and central. So we're not ordering a lot of extra computers. We just have one measly computer. And one of the campuses is not going to be happy just by adding one measly computer. Let's make a table. So we're going to say campus. We're going to say population. We'll say standard quota. We'll say lower quota. And then we'll say final apportionment. We have 3 campuses, north, west, and central. Population we're given in the problem. I'm just going to write that down now. Actually, let's make a 4th row. Let's call that total. So when it's all said and done, for this first go-around, that lower right number is going to say 600. And then the second go-around, that lower right number is going to say 601. Is that okay with the problem? Okay. Okay. So what is the current total population of the students? 12,000. Wow, how nice. What a nice whole number that is. Okay. Well, off to the side here, we have 600 items being allocated. So according to Hamilton, we take the population divided by the number of items being allocated. What do we get? 20. Oh, how nice. What a nice, pretty number that is. So now to find the standard quota, we take the populations and divide them all by 20. And we go to 2 decimal places. Actually, I think it turns out nice where it rounds to 1 decimal place. But that's okay. So I got, for north, I got 276.3. For west, I got 223.3. And for central, 100.4. So for the lower quotas, we just ignore the decimal part. So north would be 276. West 223, central 100. What is the sum of the lower quotas? 599. Which means we have 1 computer left to allocate for the first go-around. According to Hamilton, you give it to whoever has the largest decimal portion. Who gets it? C, central. So the final apportionment, 276 for north, 223 for west, 101 for central, and that adds up to the 600 that we wanted. So that's phase 1. So now we're going to buy 1 additional computer. We're going to do this whole thing again. I'm going to shrink this down, recreate the chart, but we go back to the beginning. The population won't change, but the divisor is going to change. Instead of being 12,000 over 600, it's now 12,000 over 601. Go ahead. Questions on phase 1? All right, phase 2. So I'll say campus. There's supposed to be a P in there. There it is. Nailed it. We got population. We got standard. We got lower. We got final. North, west. Okay. So off to the side here, we're going to do 12,000 divided by 601. What is this at 2 decimal places? $19.97?
What are we rounding?
To 2 decimal places. Yeah. Yeah, well, to go to 2, you look at the third place.
Okay, yeah.
So since that's a 6, we round the 10th place to a 7. Yeah. So now we're going to take the population and divide by 19.97. That was a good year. 19.98, not so much. If you would, find the standard quota and then find the corresponding lower quota and their totals. So the final apportionment, your lower and upper quotas are whole numbers. Everything else is 2 decimals. What do you get for north standard quota? I got 71. Would you, what was it, 7? Oh, it was 715? But not 7149 or anything? It was, okay, then that is 712.72. Let me make a change in my notes. It doesn't actually affect anything, but it's, you never know, you might be down to the hundredths place. And then west. Yep. And central. Good. So ignoring the decimals becomes the lower quota. We got 276, 223, 100. What is 276, 223 plus 100? 599. But this go around, how many total computers are there? 601. So we need to apportion 2 more computers. So according to Hamilton's, who has the largest decimal portion? North. So north goes up by 1 to 277. And then the second largest? West. Goes up to 224. Central stays at 100. Now we're at 601. So comparing to what happened before, the first go-around, Central is at 101. The second go-around, by adding 1 additional computer, Central lost a computer. They went down to 100. So this is the Alabama paradox. We added 1 additional item. It doesn't matter how many you add, just that any addition will decrease someone's allotment.